Mr. Mass here. Today's lesson is about measures of disbursement, and your assignment this week is going to be on Study Island. It's going to deal with things like median, range, interquartile range, kind of things related with box and whisker plots. And to help me today with this, I have my wonderful and talented daughters. First up, we have Ellie. We're just showing off some random tricks. And now Jenna. And their first task is going to be to give me some different items. I think I hear them coming back. Wow, that was fast. Nice work. You can go ahead and set those things on the table over here. Wow, that's a lot of good stuff that you girls brought back. All right, so your next task, and in trying to find different measures of disbursement, we have to put everything in order. And for these items, I think the best thing to do here is to put them in order of height. Let's go from shortest on the left to tallest on the right. Have at it. All right, so they got a lot of items and they put them in order from least to greatest, as you can see here. Oh, there they are, acting totally normal. So now what we're going to talk about is the different measurements and specifically how to arrange these in kind of a box and whisker plot. The main idea between a box and whisker plot is something called quartiles. And if you notice from the name quartile, quart is in it, which means 4. So we're going to split all of these objects into 4 groups. So we need to kind of count them and figure out how many should be in each group. So I'm going along the line here and starting with the Minnie Mouse keychain. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 items. So we've got an odd amount here. Speaking of odd. Step 1 in finding all of the different quartiles is to find the object that's in the middle, or the median. So the girls are going to use a strategy to figure out which object is in the middle, or the median. And like a lot of people do with a list of numbers, they're kind of crossing it out from end to end, and they ended at the watering can. So the watering can is the object that's in the middle. So that's going to represent the median. We found the median here. Now we have 2 halves here. And to split it into quartiles, we have to take each remaining half and find the middle of each of those. So the girls are going to do that now to find out the middle object for each of their sets. So we got the little K cup and the little K cup, we call that the lower quartile because those are the lower heights, the lower numbers. And up here we've got this turquoise container and we call that the upper quartile. And once again, they're just medians. So the watering can was the median of the whole thing. The K cup was the median of the lower half, and this teal container is the median of the upper half. So now, go ahead and split them all out. We have 4 groups, and you'll notice 4 items in this group. Then we have the quartile, 4 items in this group, and then the quartile, 4 items in this group, then a quartile, and then 4 items in this group. So the box and whisker splitting up into quartiles is really just splitting them up into even groups. And when you have odd numbers, that middle object is going to stand out as the median, or the lower quartile, and upper quartile. The next thing to talk about are ranges. And when you're looking at just a normal range, that's talking about what's the difference between the maximum, which is the horseshoe curve book, and the minimum, which is the little Minnie Mouse keychain, but we couldn't get her to stand straight up and down, so we were just using kind of her height when she was laying on her back. So let's check out what the range would be between these. So we go from the height of Minnie Mouse to the height of the horseshoe curve, which is about that big. let's try to get a little bit more consistent and accurate here. There you go. That looks good what Ellie has right there. Now the other range, all right, so there is the range from the minimum to the maximum, but there's also something called the interquartile range. So the interquartile range is the range between the lower quartile, which is a K-cup, and the upper quartile, which is this container. So the interquartile range would represent the distance between those two. So if you put them side by side, you can kind of see what that interquartile range would look like. All right. Now, the interquartile range, what that really represents is the box in the box and whisker. So if we place everything back where it belongs, we mentioned that we split these in quarters, and 2 quarters make a half. And usually the most significant part of a box and whisker or of this data is the middle half, which is where the quartiles come into play. So from the coffee to the container, that would represent the middle half of these objects, and that would be our box. Let's start taking a look at some of the types of problems that you're going to have here. First one has some data of test scores for Kathleen and Joey for their first semester. And this particular question is asking about the ranges, comparing the ranges of Kathleen's test scores and of Joey's test scores. And the range is simply taking the maximum, which is the highest number, and subtracting the minimum, which is the lowest number. So for Kathy, we need to identify the maximum. And looking at this list, it's not in order, so that doesn't make it too easy, but it's not terribly difficult. The max is 75. That's the highest. And the minimum is actually right next to it at 41. So we are taking 75 minus 41, and excuse me, and that gives us a range of 34. So then we look at Joey. Let's go ahead and change colors here. So Joey's maximum, looking at that list, is 96, and his minimum is 54. So his range would be 96 minus 54, which is 42. So then we're going to compare these two ranges here. We're going to compare 42 and 34, and we know that we're looking at Kathleen. Kathleen's is lower than Joey's, and it's lower than Joey's by 8 points. If you just simply subtracted 42 minus 34, you see that there is a difference of 8. So Kathleen's scores are less than the range of Joey's scores by 8 points. So the next question looks at a box and whisker, and this box and whisker talks about the average rainfall per month in inches for the last year. And as we mentioned, a box and whisker plot splits things up into quartiles or fourths. So if we think about it, we have 12 months in a year. That means each quartile represents 3 months. So there are 3 months here, there are 3 months here, 3 months here, and 3 months here. So that's extremely important to recognize while we're answering this question. So A says 3 of the months had 2 inches of rainfall or more. And if we look at 2 inches of rainfall or more, that deals with the top 3 quartiles. So that's actually 9 of the months had 2 inches of rainfall or more. The next one, 3 of the months had 2 inches of rainfall or less. So here's 2 inches of rainfall or less, and that happens to be 3. So that is the correct answer there. And just continuing on to look at the other ones, 6 of the months, so that would be 2 of the quartiles because that's half of the months. 6 of the months had 2 inches of rainfall or less. That's obviously incorrect. That was 3. And 9 of the months had 1 inch of rainfall or more. If we were looking at that, that actually ends up being all of the months. So it should have been 12 of the months had 1 or more inch. So now we have a great problem here about a county fair that holds a grape eating contest, and there were 13 contestants, and the number of grapes eaten by these 13 contestants in 30 seconds are listed below. and they want to know the interquartile range of the set of data. Now, if you remember from the early parts of the video, in order to do anything with box and whisker to find quartiles, or in this case, the interquartile range, we have to put the numbers in order first of all. So let's go ahead and use our little magic here and bring up those numbers in order. All right, so I put all of these in order. Now, one thing to keep in mind, when you're trying to put these numbers in order, it's very easy to lose track of the numbers. So what I recommend is actually going ahead and, as you're writing them down, cross them off. So when I wrote down 61, I would have crossed off 61, and then 65, I would cross off 65, and then 66, and so on and so forth. And then just to kind of double check, I know that there are 13 contestants, so I would count to make sure that I had 13 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if I didn't have 13, I would go back and double check to make sure that I did. All right, so now, looking at the interquartile range. Once again, quartiles mean force. So we have to split this into 4 numbers. So we're just finding medians here. So if I have 13 numbers, I know there should be 6 numbers on each side of that median, and the median would be right in the middle, making the 13th number. So that ends up being right here. That's my median. And you notice that I have 6 numbers on the left and 6 numbers on the right. So 73 is indeed my middle number. And then to split that in half, we notice that we have 6 numbers, so we're going to split that right in the middle. So between 66 and 67, and between 79 and 79. Now, when you're taking the median of an even amount of numbers, we have to take the average of those 2 numbers, or really what's right in the middle of 66 and 67, that is 66.5. And little different situation on the other side, right in the middle of 79 and 79, since it's the same number, that's just 79. So these represent the interquartiles, and the range just means how far apart are these numbers. So range is, let's subtract them. 79 minus 66.5 gives us 12.5. So the interquartile range is 12.5. I didn't mean to circle the 21. I don't want anybody to be confused. So we've got 12.5 for the interquartile range. This is going to be one of the more challenging problems that we see because we have to find the IQR or interquartile range twice. So we have Robert and Blake, both competitive hot dog eaters with their last 7 hot dog eating competitions listed below. And before we can find the IQRs, the first step is putting these numbers in order for both Robert and Blake, and I have conveniently done that down here at the bottom. So now, once we have them in order, we have to find the median so we can find the quartiles. There are 7 each, so the median is going to represent this 4th number, the one that's right in the middle, and you can see we have 3 on each side. And then the quartiles, remember, are going to be the medians of the lower and the upper half. So we've got here and here would be the medians of the lower and the upper half. So for Robert, his first quartile is going to be 9. For Blake, his is 17. And the upper quartile, called Q3, or the 3rd quartile, for Robert is 13. And for Blake is 22. So the IQRs, or interquartile ranges, for each of them, Robert has an interquartile range of 4. That's the difference between 9 and 13. And Blake's is 5. So we're going to use that information to answer the questions. So they're talking about Blake in relationship to Robert. So Blake's interquartile range is 1 hot dog greater than Robert's interquartile range, which is B. Your assignment for Monday and Tuesday of this week is going to be called Measures of Dispersion, and it is on Study Island. It's just 10 questions long, and you have unlimited attempts to get the best score you possibly can. Also, don't forget that I am available to Zoom for help every single Monday, Tuesday, Thursday, and Friday from 11 o'clock to 11:55 during your 3rd period class, and also during my office hours at 11:30 or 1:35, whatever is most convenient to you.